All right, hello everyone. Today we're going to talk about tree diagrams and the counting principle. So tree diagrams help us figure out when we have more than one event or more than one action or choice happening at the same time. So for instance, if you roll a die and then you spin a spinner, or in this case, if we're looking at number one, we spin the spinner once and then we spin it again. Most people would say, well, there's only 6 choices. You have 3 choices the first time and 3 choices the second time. But I'm going to show you that there are actually more choices than that. So when we're looking at this, we have the choices of A, B, and C. But then when we spin it again, we also still have those choices of A, B, and C. And then if we spun B first, we still have the choices of A, B, and C the second time. Same thing with C. So then over here in what we call the sample space, I am going to write out my choices. So I have AA, meaning I went like this, AA. Then my next choice would be AB, and then I would have AC. So if I spun A, then I got C. So my next choices would be BA, then BB, and then BC. So see how I'm already at 6 choices, and originally we thought there were only 6. All right, and then my 7th choice is going to be C and then A. My 8th choice would be C and then B. And my 9th choice is C and then C. Now, if we're looking at choice number 7, seeing that it's CA, that is different than choice number 3 that is AC, because they were in a different order. The order does matter. So when we're figuring out probability, we see that we actually have 9 choices. So all of my totals, or my denominators, are going to be out of 9. So when I see B twice, if I look at my sample space, there's only one time that B shows up twice, BB, and that is answer choice number 5. When I see part B, it says the probability of at least one A. So at least one. Well, I have 1, in that case, 2, 3, 4, and 5 choices there. So I have 5 that give me at least one A. The first one actually gave me 2, and that's fine. So now I have to look for the choices that do not give me a C at all, which is 1, 2, 3, 4. So there are 4 answer choices that do not give me a C at all. All right, so now we're going to come down here. I'm going to do that same thing. Here we're at a popcorn stand, and it offers buttered and unbuttered, and then it comes in 3 sizes, small, medium, and large. So I have buttered and I have unbuttered. And out of those choices, I then have small, medium, and large. Small, medium, large. Small, medium, and large. So now over here, I'm going to do my sample space. So my sample space for number 1, I could have buttered with a small, buttered with a medium, and buttered with large. I could also have unbuttered popcorn as a small, unbuttered as a medium, or unbuttered as a large. So there are only 6 answer choices this time. Remember, probability, the total always goes in the total number of outcomes in the bottom. All right, so here we have buttered popcorn. There are 3 choices that give me buttered popcorn. If you divide by 3, that means 1/2. Okay, a large popcorn, there's only 2 of them that give me large. So when I do that, I get 1/3. And with a small with no butter, there's only 1 choice for that, and that's answer choice number 4. All right, so here is this one. So if we want to look at this, we have a choice of ice cream, vanilla or ice cream, and we can only get 1 topping. So that's what we're applying, not getting more than 1. So we can have vanilla or we can have chocolate. And then out of those, we can have sprinkles, we can have peanuts, we can have granola, or we can have M&Ms. Sprinkles, peanuts, granola, or M&Ms. And then I'm going to create that sample space over here. Alright, so I have vanilla with sprinkles, vanilla with peanuts, vanilla with granola, and vanilla with M&Ms. I have chocolate with sprinkles, chocolate with peanuts, chocolate with granola. Whoops, did that one wrong. There we go. With granola and chocolate with M&Ms. So I have 8 choices. Alright, so if I'm looking at this, choices of chocolate, I have 4 of them. Didn't matter the topping, so that is half of my choices. With M&Ms, I only have 2. Answer choice number 4 and number 8. So when I divide by 2, I get 1/4 of my choices with M&Ms. And vanilla and sprinkles, that is only answer choice number 1. So the answer is 1/8. Alright, so for this one, we're done doing the practice together. There is no actual homework that you have to submit, but I advise you below to pause this video. And then once you finish this on the notes, remember that's on Canvas, you can then check your answers. So go ahead and pause the video at this time. Alright, welcome back. So here are your answer choices. I'm going to go ahead and leave those up there. Please pause the video again. That way you can double check your answers before I move on. Alright, so hopefully you got all of those answers correct. And now we're going to look at what we call the fundamental counting principle. The fundamental counting principle says if you multiply the number of choices by the other thing happening with the number of choices, you will get how many outcomes there are going to be total. So when we look at this, if I have 5 activities to choose from in the morning, and then I only have 3 more in the afternoon because it's raining, I actually have 15 ways to do different activities, first and then second. So all we have to do is multiply. I'm going to bring up my calculator over here to the side so that we can save a little bit of time in that multiplication area. So here it says, to leave her office, Karen chooses between 3 sets of stairs. So 3 and then 7 doors. How many possibilities? Well, 3 times 7 is 21. All right. Then on number 2 here, it says I have 4 sizes of sweaters and 8 colors. So 4 times 8 gives me 32. All right, over here we have 11 boys and we have 16 girls. How many ways can the teacher pair that choose them differently? And this one's a little bigger, so I'm going to use my calculator. Now, if you want to do it longhand or using lattice, you still get 176. All right, so now 4, it says a dinner menu consists of 5 appetizers, so 5, and 12 entrees and 3 desserts. Remember, the order doesn't matter when you're multiplying, so if you want to do 5 times 3 and then times 12, you'll still get 180. If you were to do it as 5 times 12 times 3, again, still 180. Alright, so a card is chosen from a standard deck and then a die is rolled. If you didn't know this, there are 52 cards in a deck of cards. And a die has 6 numbers on it, 1 through 6. So 52 times 6 is 312. Alright, a quarter is tossed, so that's either heads or tails, just 2 choices. Then a letter from the word snowflake is chosen, and snowflake has 9 letters. Okay, and 2 times 9 is 18, so I have 18 choices there. On number 7 here, a day of the week is chosen, then a spinner to the left spun twice. Alright, so now I have to look at the spinner. So this spinner has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters on it. And there are 7 days in a week. And it says that the spinner is spun twice. So a day of the week is chosen, and then it's spun again. I know that 12 times 12 is 144, so I just need to multiply that by 7. Or I could do 7 times 12 times 12, and I still get 1008. Alright, my next one. How many ways can someone randomly dial a 7-digit phone number? So, out of the digits of numbers that you can choose for a 7-digit phone number, there is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is actually 10 choices. So we're going to multiply 10 by itself 7 times. And I'm sorry if you can hear my dogs wrestling in the background. So 10 times 10 times 10 times 10 times 10. That's 5 times. 6, 7. So we have 10 million possibilities. And really, a phone number actually has 10 digits because there is the area code as well that we have to account for. And we could have also known that when you multiply by 10, it's just 1 with how many zeros after it. So in this case, 7. All right, so a quiz has 5 multiple choice questions, so 5 multiple choice, and 4 answer choices for each. So that means that there are 20 possible solutions. All right, number 10, it says library codes on their books involve 2 letters. So there are 26 letters in the alphabet. So we choose 2 letters. They can be the same. And then followed by a digit 0 through 9. So that's 10 digits. So we're going to do 26 times 26 times 10, which gives us 6,760. Okay, on to our last 2 here. And then the following ones you can do on your own and check yourself. So it says Patrick is buying a new car. He can choose the body, style, the engine type, and the color. If there are 54 ways, he can select a car with 3 body styles, 2 engine choices. How many colors can he choose from? So we're going to call that C. Okay, so we end up getting 54 equals 3 times 2, which is 6, times C. So in order to solve an equation like this, we divide by 6 on both sides, and we end up getting 9 color choices. And we know that there are 9 color choices because our fundamental counting principle says that the number of choices multiplied by number of choices by number of choices. So if we double check, we have 9 colors times 3 is 27 times 2 engine choices, which would give us 54. Okay, our next one here says at the school cafeteria you can choose one sandwich and 1 snack and 1 drink. The number of drink options is equal to the number of snack options. If there are 63 ways to choose your lunch and 7 sandwich choices, how many drink options do you have? Well, remember that drinks are the same as snacks. So drink times drink. So this is really saying 63 equals 7D squared, because D times D would give you D squared. So I'm going to divide both sides by 7. So I end up getting 9 equals D squared. And to unsquare something, I take the square root, and the square root of 9 is 3. So there are 3 drink choices. And I can always double check my math by taking 3 times 3, which is 9, times 7 gives me 63. So it is correct. And like I said earlier, you may want to pause this video so that you can do the next problems. I think it's 13 through 17. Go ahead and pause, and then I will let you do that at this time, and you can double check your answers shortly. Alright, welcome back. You should be able to check your answers at this time. I'm going to zoom out so you can check all your answers. If you do have any questions or need help, please make sure that you are asking for help, because I don't know if you need help if you don't ask. So those questions 13 through 18 are kind of helping you figure out using the fundamental counting principle and tree diagrams. Now, no matter what, you can always use tree diagrams for all of them. It just would take you a little bit longer, especially with like number 15 when you have 104 choices in your sample space. Hope you have a great day, and see you later.